Fundamentals of Algorithmic Problem Solving. To solve any problem using algorithm, a sequence of steps is needed. The first one is called as understanding the problem. The first thing you need to understand completely the problem given. Read the problem description carefully and ask questions. If you have any doubts about the problem, do small examples by hand. The second steps, ascertaining the capabilities of computational device. In majority of the algorithms are still designed for von Neumann machine, that is called as random access machines. Here in these machines the assumption is made that instructions are executed one after the other, that is called as sequential order. The algorithms designed for such machines are called as sequential algorithms. But nowadays computers are executed in parallel. Instructions are executed in parallel. So the algorithms which is designed for such machines are called as parallel algorithms. In the next step, we have to choose between the exact and approximate problem solving. Here the question arises, if there is an exact problem solving, why we need approximate problem solving? Okay, we have to do some decisions where we have to use approximate or exact. In some situations we have to select approximate problem solving. The reason is there are some important problems are there that simply cannot be solved exactly for most of their instances. For example, square roots, extracting square roots, solving nonlinear equations, and evaluating definite integrals, etc. And second reason is some available algorithms are very slow whenever the problem is very complex. In such situations we have to use approximate problem solving. The next step is called as algorithmic design technique. An algorithmic design technique is a general approach to solving problem algorithmically. It's a general approach actually. So why we need some algorithmic design techniques? The reason is they provide some guidance for designing algorithms for new problems, that is problems for which there is no known satisfactory algorithms. The second reason for that selection is algorithm design techniques make it possible to classify algorithms according to underlying designing ideas. The next one is called as designing an algorithm and data structure. Designing an algorithm for a particular problem may still be a challenging task. Some designing techniques can be simply inapplicable to the problem in question. Sometimes several techniques need to be combined. One should pay close attention to choosing data structures appropriate for operations performed by the algorithms. Next step one is called as methods for specifying an algorithm. Whenever you specify an algorithm, there are two methods are there. The first method is called as natural language. In the natural language, the language contains ambiguity that makes the algorithms difficult to understand. The second technique is called as pseudocode technique. Pseudocode is actually a mixture of natural language and programming language like constructs. Pseudocode is usually more precise than natural language. So most of the designing algorithm specification is done using pseudocode. Next one is called as providing an algorithm correctness. Designing algorithm is not sufficient. We have to check whether it is working correctly or not. You have to prove that the algorithm yields required result for every legitimate input in a finite amount of time. That is the important point we have to remember. A common technique for proving correctness is to use mathematical induction. In order to show the algorithm is incorrect, you need just one instance of its input for which the algorithm is fails. If any one input is fail means the algorithm is not working correctly. Analyzing an algorithm. After the correctness check, we have to check the efficiency. Efficiency can be calculated using two techniques: time efficiency and space efficiency. Time efficiency means how fast the algorithm runs, and space efficiency indicates how much extra memory it uses. Apart from these two, we have to consider two more characteristics such as simplicity and generality. The last part of the designing is called as coding algorithm. Most algorithms are designed to be ultimately implemented as computer programs. That means we have to convert the pseudocode into the actual programs. When implementing the algorithm as a program, we have to use in actual applications. You should provide specific inputs and check the verification. The working program provides an additional opportunity in allowing, analyzing and understanding the algorithms. We can analyze the time as well as space efficiency in code also.